Hey people, welcome back. And in today's session, we are going to understand about what are the fundamentals of hypothesis testing. So we talk about probability of any event. So there are two chances of anything, either it will happen or it will not happen, right? So we say on a scale of 0 to 1 is what we will measure, or you can say 0% to 100%. The probability of any event, it will happen or it will not happen, lies between 0 to 100% or 0 to 1. So there are two types of hypothesis. First, hypothesis means, what is the hypothesis? Hypothesis is validation of assumption. Whenever we start validating any assumption or any sample data, so assumption validation is what? You collect your sample data. You analyze sample data, understand the statistical distribution of that sample data, and based on that, your probabilistic statement will talk about the population, which means if my sample is like this, will my population be like this or not? So that is what hypothesis. So there are two types of hypothesis. When we say probability, probability will depend on two things. One, you have the assumption, and then you have the actual, all the results based on the sample data. Assumption you are making before testing the sample data, and actual result you will get after testing the sample data, right? So there are two probability, either it will meet the requirement or it will not meet the requirement, and chances for both lies from 0 to 100%. So when you are making an assumption and doing the testing, after testing you are getting the actual result. Suppose you have a target, like as you got a new production machine or maybe new process you are setting up, or some of the new recruits are there, and you are making the assumption. Suppose this is a training you are giving to them, or maybe machine maintenance you have done. So you are making assumption that you will meet the production target. You are making an assumption that you will meet the production target. Now, in actual, when you collect the sample data, maybe like as people, you have trained new people, they are on the floor maybe in a week or something, and you are assuming that they will meet the target or the new machine maintenance you have done. And after doing the maintenance, you are assuming that machine will run as it is expected, which means it will be able to produce the number of product you want. So this is your assumption. Now, actual, if you will see, after collecting the sample data, suppose that meet the production target. So do we see any difference here? Answer is no, that there is no difference. What I assumed, actually based on the sample data, I got the same thing. So this kind of hypothesis is called as a null hypothesis. This hypothesis is null, which is denoted by H0 or H0. And this is represented in the form of p-value, but actually you are running the hypothesis test and you will get the p-value. So in this case, if you are looking at 95% of confidence level, then your p-value, the threshold will be 5%, which is the risk level. And actually you are crossing the risk level what initially you have assumed. Because when you have done the maintenance, you was assuming I may meet the target or I may not meet the target. So you are taking a 5% of risk. So when you are running the initial sample at the start only, maybe in the day 1, day 2, maybe 1 hour, 2 hour, when actually machine is running. So then you found that actually you are meeting the target, machine is running as per the expectation. So your hypothesis is proven as what was your assumption, you will meet that actual number. So you are crossing the risk level and the p-value will be greater than 0.05. Now, in case you are preparing a report. Report means you are telling, okay, machine is working fine or not working fine. So when you are preparing a report for the machine performance and you are putting in the machine performance, which is your practical decision you are taking, and you are telling, yes, based on the testing I have done or trial I have done, machine will meet the production target. So are you making any decision error here? Answer is no decision error, because your statistical decision, what you have validated from the sample data, this was your assumption for that sample data. This is your actual sample data is telling, and the same thing you are writing in the report. So this actual is coming from the statistical analysis or statistical decision. And your statistical decision is in sync with your practical decision. Then we are not making any error. There may be another case. Let's say this is the case we are taking as positively. If we take the case as a negatively, you have done the maintenance. And after doing the maintenance, your assumption was you will meet the production target. But actually, your machine did not run in the way that it should meet the production target. And you are assuming that machine will not, you will not meet the production target. So there is any difference in assumption and actual? Answer is yes, you was assuming it will meet the target, but actually it will not meet the target because machine is not running as you are expecting on the sample trial. So this hypothesis is called as an alternate hypothesis, which is denoted by H1 or HA. In this case, your probability value at 95% confidence level will be less than or equal to 0.05. And now you are writing a report and you are telling to your manager or maybe to the maintenance team or maybe someone else that what analysis I have done, I have run the sample trial, but machine is not performing as expected. So you are telling to them that machine will not meet the production target. So again, in this case, your statistical decision is the same what you are taking the practical decision. So you are in sync with the statistical analysis. So again, there is no decision error you are taking. There may be a third case when I will say that your assumption was you will meet the production target and actually you meet the production target. So there is no difference. This is a case of null hypothesis and p-value will be greater than 0.05. But by any reason you could not sync with the statistical decision, and now you are writing a report that machine will not meet the production target. So you are making a decision error here. Answer is yes. And this kind of decision error is called as a type 1 error. Sometimes we call this an alpha error. Sometimes this is called as a false positive, or this is also called as a producer risk. These are the different names of making a type 1 error. So when we create a type 1 error, when actually what was your assumption, your statistics is proving that you are meeting the assumption, but you are taking a opposite decision practically, then the type 1 error, alpha error, false positive or producer risk will come here. In simple word, I will say, in real world, you have the null hypothesis, which say no difference, but you are telling it to alternate and you are telling there is a difference. This is what the simplest way to remember. When you say null to alternate, actually there is a null hypothesis, but you are telling no, it's a alternate, then the type 1 or alpha error will occur. The opposite case of that, you have a assumption that you will meet the target, And actually, your machine is not working in a way to meet the target. It needs some maybe further maintenance or anything else. So there is a difference here in your assumption and actual. So this is the case of alternate hypothesis, and p-value here will be less than or equal to 0.05. And now you have to take the practical decision, and suppose you are making a false report and you are telling no, we will meet the target. So in this case, again, you are making a decision error. Actually, your sample data is telling no, you will not meet the target, but you are making a false report telling to the production and maintenance, no, we will meet the target. So this kind of error, actually it's a alternate hypothesis. And when from alternate, you are presenting as a null hypothesis that you are meeting the assumption, this type of error is called as an type 2 error or beta error. This is called as an false negative, or we also called as an consumer risk. These are the different names of these basics of hypothesis testing. So hypothesis works on two things. First, you make an assumption. We are making the assumption or the confidence level statistically. By default, we work at 95% confidence level. So when you make a decision, what are the chance of error? Chance of error will always be 1 minus confidence level. That you may make a mistake as well here. So this is around 5% of chance. In case your confidence level is suppose 99%, then the chance of error you are leaving 1%, or maybe you are taking a 90% confidence level, then chance of error will be 10%. The best example for this, if I could do, suppose there is a elections happening and many of the news channel or maybe another survey agencies, they will be publishing the opinion poll. So they will not go and talk to each and everyone. They will just ask few of the voters, and based on that, they will make their assumption for a particular constituency who is going to win. They are always taking a 5% chance of error, and many times you have seen what they are predicting, actually that is not true. Maybe they are predicting that X person will win the constituency, but actually the person will not win. That means they are making a decision error. Or many a time, they will say this person will not win, but actually that person turned out to be a winner. So here, when you have the sample data, what is the need of hypothesis testing? Because testing the entire population will be too expensive and too time consuming. To save the time and expenses, we collect the sample data. And when you are doing the sample data testing and predicting about the population, then we perform the hypothesis testing. So hypothetically, we make some assumption about the population. That assumption we validate with the sample data, and what my sample data is telling, according to that we take the practical decision, and that is what all about the hypothesis testing. For any question, mention in the comment, I will answer that. Thank you so much, people. I'll see you in the next session.